Assalamu alaikum kids. So in this video we are going to learn how to scale vectors. So the very first thing that you need to do before you start adding vectors is to scale them. Now the idea is very simple. You scale a vector by drawing or by determining what the length of that vector is going to be on paper. So let's say for example you have 20 Newton vector and you can see that you have tons of scales that you can choose. You can choose 1 Newton is 1 centimeter. You can choose 2 Newtons as 1 centimeter. You can choose 3 Newtons, 1 centimeter, so on and so forth. Now, given that you have a lot of scales that you can choose from, which are the appropriate scales to choose? Again, we are going to talk about that in this video. All right, so stay tuned. So what are the appropriate scales? Let's talk about scale number 1 and scale number 2. Now scale number 1 is going to give me an arrow length of 20 centimeters and scale number 2 is going to give me an arrow length of 10 centimeters. Now these are too long, all right? You probably won't even get the space of drawing 20 centimeters on your question paper. So again, these two scales should not be used. Then you have scale number 3. Now scale number 3 is 6.67 centimeters. Now again, you can draw 6.6 centimeters, but you cannot draw 6.67 centimeters using a simple ruler. So there are situations that may require you to use a scale that gives you non-integer values. So let's say, for example, if you have 10 and 11 newtons, now you need to draw 10 newtons and 11 newtons on the same diagram. Of course, you'll have to take the scale as 1 centimeter is 2 newtons, and that's going to give you 5 centimeters for this one, but 5.5 centimeters for this one. So again, all right, you may take scales where you do not have common factors between the lengths that you or the vectors that you want to draw. But again, at the same time, the maximum number of decimal places that you can get is 1. Again, your scale cannot measure in 0.0 millimeters. So let's say, for example, I want to draw 5.87 centimeters. Now I can draw 5.8. I cannot draw 5.87 centimeters. It's either going to be 5.8 or 5.9. All right. So that's something that you need to be careful about. All right. So moving on. Another set of appropriate scales would be 4 and 5 that give you 5 centimeter and 4 centimeter lengths. All right. Now these two are the most appropriate to be used. Why? Because they give you a length in between 4 and 10 centimeters. Now these are lengths that you can comfortably draw, but you do not want your lengths to be less than that either. So let's say, for example, you have 8 and 10 newtons per centimeter that give you 2.5 and 2 centimeters respectively. Again, that's a scale that should not be used. Why? Because the lengths are too small and you won't be able to draw an accurate diagram, or even if there's a small error, it's going to give you a very big problem. All right, so these right here are the appropriate, or this is how you're going to choose an appropriate scale to draw a vector on a piece of paper. Now let's do some examples. So let's say I have a 30-meter vector. All right, so I want to draw a 30-meter vector. I'm probably going to say that 6 meters represents 1 centimeter. All right, and then I'm going to go with 30 divided by 5 is going to be 30 divided by 6 is going to be 5 centimeters. On the other hand, I could go with 5 meter represents 1 centimeter, and I could go with maybe 5 meters represents 1 centimeter. So I can go with 30 divided by 5, and then I can go with a 6 centimeter line. Both are fine. So going with 10 meters is 1 centimeter will give you a 3 centimeter line. Small. You can go with 1 centimeter is 3 meters is 1 centimeter. That's going to give you a 10 centimeter line. Again, that's a risky business. Maybe you have the space to draw it, maybe you don't. Then you have a 12 meters per second square acceleration. Okay, so I'm probably going to go with 12 divided by 3. All right, and that's going to give me 4 centimeter line, or I could go with 12 divided by 2, and that's going to give me a 6 centimeter line. All right, then I have 0.45 newtons. So whenever you get something in decimals, just ignore the decimal place. So I have 45 newtons. I can either go with 0.45 divided by 0.09. So like I said, if you keep the decimal places, it's going to be a little confusing. Just remember that you are taking away 2 decimal places. You need to put them back as well. So think of 45, and then I can divide this by 9 to give me a 5 centimeter length. Or I could say that, okay, I can take 45 divided by 5. I could take a 9 centimeters. So both of them would work just fine. Then you have a 40 meters per second velocity. So again, here I have a lot of different options. So I can go with 40 divided by 8. That's going to give me a 5 centimeter line. I can go with 40 divided by 5. That would give me an 8 centimeter line. All right. Then I have 10 newtons. The best way to go about this would be 10 divided by 2, which is going to give me a 5 centimeter line. And then you have 0.48 newtons. Like I said, ignore the decimal places. So it's 48. I could either go with divide by 6, which is going to give me an 8 centimeter line, or 48 divided by 8, which is going to give me a 6 centimeter line. Both will work just fine. Then you have 7.5 meters per second. So you can go with, again, ignore the decimal place, 75. So you can go with 75, maybe divide by 15. That's going to give me a 5 centimeter line. Again, if you can think of some other scale that you can use over here, maybe you can go with 75 divided by 10, which is going to give me a 7.5 centimeter line. All right, but you should not go for 25 meters per second square represents 1, because that's going to give you a 3 centimeter line. So I could go with divide by 25, but that's going to give me a 3 centimeter line. I should not go with 75 divided by 3, which is going to give me a 25 centimeter line. All right, so those would be scales that would not be appropriate to be drawn. Again, this is too short and this is too long. All right, then you have 700 meters. Now again, you can go with 700 meters in a lot of different ways. The best one would be 100 meters is 1 centimeter. So 700 divided by 100, and that's going to give you a 7 centimeter line. All right, so this right here is how you are going to scale a vector to be able to draw it on a piece of paper. So what is the appropriate scale, which appropriate scale you should use? That's a very, very important thing to remember. All right, in the next video, we are going to talk about how the directions of a vector can be determined. All right, so I'll see you there. Bars out.